As our systems grow, so does our infrastructure, and with software, it's no different. As these SaaS companies get bigger and bigger, their reliance on external services and third-party application grows. And fortunately for us as hackers, this puts them in a great position to be targeted by these third-party misconfigurations with really high impact. And today I'm going to be focusing on 3 reports that specifically target infrastructure of these companies. And honestly, they're really good, and I learned a lot from these techniques. So if you want to have a read of them, link is in the description, and we're going to hop into the first report. So the first report is a misconfiguration in Supabase. And if you're not familiar with Supabase, it's kind of like an API backend. So it's kind of like a third-party services that lets you build APIs. And what it does is it basically wraps around a Postgres database and turns the database into a REST API. It's actually pretty cool, and it's used a lot in startups who are kind of just growing and software that's kind of growing quickly because it doesn't require a lot of backend code and it allows quick prototyping. But from my own experience, I found that it's actually not that secure. Even though it's used by a lot of companies, there's a lot of stuff that's enabled by default that I think really shouldn't be enabled by default for a platform of this size. And we're going to jump into that in a second. But honestly, one of the things that was enabled by default, but luckily isn't anymore, just a few months ago, was a complete introspection into the REST API. Just one endpoint that was public that would give you the entire API. So it would give you the whole schema basically, which was really overpowered. And there's a couple of other things. One of the things that is enabled by default is signups, which for most companies, yeah, okay, that makes sense. But for some, especially who want to control their signups, it can be problematic, especially for internal applications. So this is kind of what the hunter here was looking at. Now they talk about this anon key. So in Supabase, basically there's this public key and a private key, like a lot of services. This public key is called the anon key, and it's usually going to be embedded in the application. So this is a good indication that Supabase is being used, and normally it's also on a separate URL. So there'll be like a project URL which links to .supabase.co, which is where the actual REST APIs will be stored. Now the Supabase endpoints are all very public. You can ask AI about them. There's a lot of recon there you can do. It's a very rich attack surface. So that's what I would recommend doing if you see Supabase, and especially one of these project URLs. And I would just try the default stuff because more often than not, it's going to be enabled. Now, one of the things that the hunter found was that here sign up was enabled. So on the application they were testing, they were able to use some random email and then sign up was enabled. And then also email confirmation was apparently auto enabled, which is interesting. I wouldn't have seen that myself, but apparently that's what it was here. If you actually want to find out more about the sign up process, you can check this endpoint called auth/v1/settings. And what this endpoint does is it basically gives you all of the auth information. So exactly which third-party providers are enabled, whether anonymous SMS signups are enabled, etc. And this is really good recon for the login page. And also remember that if, for example, signup is blocked, but you want to get an account, if there's a third-party provider enabled, then by default, you're going to be able to create an account with that third-party provider, even if you're not signing up to an existing account. But if it's like login with Google, if you click a Google account, it'll automatically create the account for you, which is a very interesting way to bypass that sign-up security. And then one of the things you can also do is you can embed this metadata into your requests. And sometimes this is used in security by the company. In this case, they basically took this role admin and then just embedded it straight into the JWT, which basically gave them admin rights on the Supabase endpoint. So that was the vulnerability basically. They were able to bypass the sign up by getting past the email confirmation, and then they were able to create an admin account. And this is a very simple vulnerability. I wanted to start with it because some of the other ones are a bit more confusing. But I really like testing on Supabase because it's hella insecure, and I think it's a great sort of surface for attacking. If you see the Supabase project somewhere, I would, instantly try and get the anon key and then try and basically enumerate it and look for its surface. Everything is publicly available. Just ask AI, it'll go straight into it. Furthermore, just ask AI to do it for you. because it's really, really easy to do it. And I would go straight in and start attacking Supabase. Some of the other things that I found on Supabase with the row level security policies, often if you find like an open GET request somewhere, like you can do a GET request and it's not authenticated, then you're probably going to be able to do like a post, put, or delete request, because most of the time, if the GET request isn't restricted, it usually means the other methods are also not restricted. So that means you have like full CRUD on it. There's also a users table often in the Postgres database. So if you can create an account, maybe you can modify the users table. I think this is off by default. However, if it's not, you can be able to just create a new admin user whenever you want to, which is kind of cool. There's like default tables and stuff which you can read into as well. Anyway, very good attack surface, and yeah, nice little 1,800 payout for basically nothing. So now we're going to move on to the second report, which is going to talk about buckets again. So this next report is about a vulnerability called bucket squatting, which is something that I didn't even know existed before reading this. But it's similar to account squatting. Basically, when an attacker creates an account and then waits for like a victim to try and register that same account to basically like take over the username or whatever. What this basically relies on is creating a cloud bucket, so a place where we can store data, then basically waiting for a company to try and use that same bucket and trying to intercept the data that they upload to the bucket. That's basically what bucket squatting is. And it kind of sounds a bit nonsensical. It sounds a bit weird. Like, why would someone use a taken bucket? But the real situation where this is used is where the bucket creation and uploading is automated. So we're hoping that an automated system regularly creates new buckets that it then basically will upload to automatically. So that's kind of what we're hoping for. And the way the hunter was able to demonstrate this was with Gemini. So I'll just skip to the actual vulnerability. So basically in like Gemini Enterprise, there was a bucket that was created for the company. This is just a Google Cloud Storage bucket or whatever. And the name was very predictable, right? So the Google Cloud Storage bucket would create a name for a bucket every time you kind of wanted to store some data. And the way it would do that was, if it wasn't already created, it would get the project number for your Google Cloud project. It would get your location, so kind of like an AWS location like US West or whatever, and then it would get the data source type. And because all of those things are basically guessable, so the project number, well, it's not really guessable, but suppose that the person would know it because it's not exactly like hidden data or whatever. And the rest of the information is basically just derivable from what the person is trying to do. When Google Cloud Bucket goes to create this storage bucket, it'll basically already run into our already created bucket. And then it'll basically upload the data to us instead of uploading it to the user's bucket. Now, the good thing about this is that when we create our own bucket, we can make it public. So we can basically have the user be able to upload unauthenticated. And then after the victim uploads their data to the bucket, we can basically read it whenever we want to because it's our bucket, we own it. And the victim can't like retract the data anymore. We can like disable that. So that's really good. We can basically hijack the victim's data using that. And this was a bug in Gemini. Why? Because this was basically automatically created, right? So this wasn't a misconfiguration on the victim's behalf. This was actually a misconfiguration in Gemini because they didn't have control over what this bucket was called. This was automatically chosen by the system. So that allowed the hunter to create this bucket, basically predict when the bucket was going to be created, the name, and then hijack the bucket name like preemptively. When the software went to create the bucket, it wouldn't be able to. It would receive probably some error, but presumably there was some failsafe whenever the bucket couldn't be created, and it just uploaded the data anyway. So that's kind of how these type of bucket squatting vulnerabilities work. And there was basically a very similar vulnerability here, which was about mounted volumes. And this was just the same one where the victim will upload data. But there's kind of another aspect of this. There's two ways we can abuse this bucket squatting vulnerability. One of them is, we can trick the victim into uploading data. That's one of the things you can do. But another thing is we could also trick the victim into reading data from our bucket, which we control. We fully control data that's on our bucket. So assuming the victim trusts the bucket and thinks it's theirs, they'll think the data is trusted on it. But if it reads from that bucket, we can manipulate the data however way we want to. So that's kind of the second attack vector for these buckets. And the way the hunter was able to show this vector was through Vertex AI. Which basically, the Vertex AI would pull some kind of, I think it was like a workflow or something. Yeah, it was called an experiment. So experiment from the Vertex AI notebook. The experiment would be stored as a pickled or serialized object onto the bucket, and then it will be deserialized later with Python. Now, if you know anything about pickling in Python or deserialization, you'll know that basically if you're able to get a server to deserialize your data and you control that deserialized data fully, then you basically have an RC on the server, because that's how the deserialization in Python works. What you can do is you can just embed like a function and it'll just run it, which is kind of weird in my opinion, but that's just how Python works. If you deserialize some data that is not trustworthy, then you'll just put RC on your server. So that's basically what happened. So the Vertex server created a bucket for this like experiment, and the way it worked is it would just take your project ID and your region. All of those things, as we previously talked about, are very guessable. We could just have to know where the victim is and what their project is. So whenever the engineer or whatever the programmer goes to create this experiment, the Vertex AI will create this bucket, or at least try to, and then pull some kind of pickled data from that. And then what the attacker can do is just preemptively register this bucket, put some kind of pickled data on it, presumably with the key that the thing is searching for. Whenever someone goes to basically use that experiment again, it'll just pull the attacker's pickled data onto the local machine. Python will go to deserialize it. The deserialization will give the attacker RC on the server, and that's basically the full chain. So you can see that this bucket squatting attack is actually very comprehensive with the things you can do. You can both basically harvest the victim data and also cause these kind of deserialization bugs, or any other vulnerabilities that require the server to read data. If it was like a JSON file and it was reading JSON, you could inject any parameters you want to, maybe just like a URL parameter, and you can put like localhost or something in it. You can get like SSRF onto it. So I think this is very cool, and I really like, attacking buckets. I think it's a great attack vector for most targets because most companies use buckets. It's a very widespread way of storing data. So I think this is a very good technique to learn, and if there's ever like a predictable bucket name, or like the service ever creates a new bucket, then you can look at this bucket squatting technique to try and exfiltrate or cause some kind of RCE, which is really nice. So shout out to Omer Amiad for this really cool report. And now we're going to hop on to the last report, which is about AWS CodeBuild and how that can lead to supply chain attacks. So the last report is in CodeBuild. And if you don't know what CodeBuild is, it's basically like a tool for testing pull requests before they're merged onto the main branch. So if you're kind of familiar with programming, you might know the concept of unit testing, which is where you take like a small chunk of the code and basically run it through a few tests and see if it works. Kind of like automated Q&A testing. And basically this is what this tool does. And it's basically aimed at these repositories where developers will be doing pull requests into them, and then the CodeBuild tool will basically make sure that everything's good with the build. It'll just do the tests on them, it'll build it, by itself, and then it will kind of flag it as working. So this is basically to speed up development, and it's run by AWS. But one of the key things about it is that in CodeBuild, you have to give it your GitHub personal access token, or like the organization access token. And what that means is that if you build a malicious pull request, then that personal access token is going to be in the memory of the container that's used to build the thing. So basically your pull request gets taken to like this other container. It's in a container, and then CodeBuild will basically build it inside the container, but your GitHub access token is inside the same container as it's building in, so that it can pull the data in. And what that means is that if you have a pull request and it gets built by CodeBuild, that means that you can basically harvest the user's personal access token from the container. Now they've been trying to patch this a little bit, and I'm sure it's a lot safer nowadays than January 15th. Okay, maybe it's not that safer, but I'm sure they've changed it a little bit since this report came out. But basically, from this report, you were able to harvest the GitHub access token from a malicious pull request. They kind of have like a diagram here. I'll show you where it is. Like here, basically, where the attacker will fork the repository, and when CodeBuild goes to build it, it'll and the attacker can basically take the GitHub access token and they'll have access to the repositories. This is just a way to take over these kind of public repositories where you're able to submit pull requests to them. And the target for them was the AWS JavaScript SDK, which is huge. This is like a huge SDK that's used like by a lot of people. So this is a big target. If you're able to take over a repository like that, you could literally like almost poison like every server out there. It's actually a very big issue. So this is a major problem if you manage to do this. To stop this, basically, what AWS CodeBuild allows you to do is basically prevent certain people from being able to create these pull requests and basically prevent the CodeBuild from building certain pull requests. So it has to match certain criteria that you define inside of the settings. And for some reason, some of them are public. I don't even know why, but for some reason, some of them are literally public and you can just check the configuration. And one of them was this AWS SDK. So they looked at it and you can see that there's a rule here created. So it will only set a build under certain conditions, as I mentioned before. And in this case, the actor ID or the GitHub ID, basically the user ID on GitHub, had to match a certain regex pattern. And you can see it here, right? So they had to have the user ID of like 47447266. For example, that had to be the user ID of the person. And this was regex. Now, do you see the issue here? If you're familiar with regex, do you see it? If you haven't spotted the issue, it's basically that when it comes to regex patterns, the regex doesn't match a whole string unless you tell it to. Regex is supposed to match only a section of the string, the part that actually contains the data. So regex doesn't verify that the whole string is actually that. It only verifies whether the string contains the data that you want it to, unless you specify otherwise. So if we look at this person again, 755743, if we just create a user that has that bit of user ID inside of it, so the number 755743 inside of it, let's say we created the user 4755,743, the regex would completely match that and it would be like, okay, that's valid, because that's how regex works. It's supposed to work that way. And that little mistake there basically means that if we can create that user ID, we will be able to create our own pull request, get CodeBuild to build it, exfiltrate the GitHub personal access token, and then get access to a repository. Sounds easy, but it's actually a little bit complicated because we have to get the user ID to be perfect, which is easier said than done. Thankfully, GitHub is a little bit easier with the IDs. They're incremental, so they go from 1 to basically the highest value. And that means that we can actually do this. So we are actually able to create a user that has a longer ID because GitHub IDs are incremental and they actually go up in numbers. So that means that we will be able to create this ID. And the way the researchers were able to do this is basically kind of through a race condition. Well, they created a GitHub like bot, like an app. And you can create, a lot of these apps with a single request. So what they did was they just waited for a time for when this ID would be available. And then they basically just spammed a lot of requests. And that allowed them to get this account with that ID. So you can see 755743 inside of it and 226 at the end of it. So that would pass the regex pattern in this case and would allow the researchers to create this pull. So then from that part, it's straightforward. They just created the pull request, the build was triggered, they were able to exfiltrate the personal access token, and they were able to get access to the AWS SDK for JavaScript, which is obviously huge. So that's very big. And that was a very cool vulnerability, in my opinion, that they found with those user IDs. And yeah, that was basically it. So this was submitted by, was it Wiz Research? So very cool report here, and I think was very informative for these kind of supply chain attacks. And I really enjoyed that. So yeah, I hope you enjoyed this video covering these type of infrastructure attacks. I've been doing a lot of them lately because it's been working. Frankly, it's a very good technique that I've been using on a lot of companies, and it's been working very well in terms of these third-party misconfigurations and other third-party vulnerabilities, and it's very good, and I think it's only growing. Honestly, it's only a growing field of research, with more and more external services, more startups joining, more companies adopting these third-party services and becoming more and more specialized. We're seeing this growing, especially since AI is now implementing a lot of it. And these developers, they don't really know how a lot of these third-party services work whenever they implement them. They're kind of just trusting that the third-party services configured security to begin with, which is not always true as well, as you can see with Supabase. But it's a really good avenue for exploitation, and I really recommend that you give it a shot. But yeah, if you enjoyed the video, then please leave a like and subscribe to the channel. And if you have any feedback, you can put it in the comments. I'll happily read it. And yeah, that's it for me. Thanks for watching, and happy hunting.